Welcome to the Pharmacy Inspection Podcast, where we discuss topics related to sterile and non-sterile compounding pharmacy in an effort to promote compliance and increase quality. The Pharmacy Inspection Podcast is a member of the Pharmacy Podcast Network, delivering quality and meaningful conversations and discussions about our pharmacy industry and the critical role pharmacists play in our healthcare systems. Learn more at pharmacypodcast.com. Please welcome your hosts, Brian Prince and Seth DePasquale.
Hello to all of our compounding friends and colleagues to episode 14 of the Pharmacy Inspection Podcast. Thank you again for joining us week after week as we strive to raise the bar for quality and safety in all things compounding. I want to give a special shout out to my new friends that I made and that I met last week in Salt Lake City while at an ACHC PCAB education workshop. Thank you so much for the nice comments and for being loyal listeners of the podcast. Don't forget to share the pharmacyinspection.com link or iHeartRadio link or iTunes or even the Pharmacy Podcast Network link. However you listen to us, make sure that you're sharing that with someone in the industry. And if you're joining us for the first time, let me give you an extra special welcome and let you know that we're always open to suggestions for new content. And likewise, if you have complaints, please direct those to Seth because that's his department. Just kidding. Just to let you know, Seth and I will be bringing our microphones and recording live at the American College of Apothecaries annual conference in Ponte Vedra, Florida on February 28th through March 2nd. Our goal is to interview industry professionals who have something to share or just something to say. And we know that you, our awesome listeners, have something to say because between the FDA memorandum that recently came out and USP announcing multiple chapter drafts to be released this year, there will be a lot of continuing discussion. So Seth and I invite you to sit down with us if you're attending the ACA conference in a few weeks, even if it's just for 1 minute, 5 minutes, or 10 minutes. This is your opportunity to make your voice heard to a growing audience of almost 1,000 listeners per week. So this week, we welcome a good friend of mine, Herschell Hitchcock with EOC1, that I've known for many, many years and who is uber smart with all things certification. I can't even begin to tell you the number of times that I've had to call him for clarification on a technical cleanroom issue. So without further ado, Herschell, jump in, introduce yourself, and let's get this conversation started.
My name is Herschell Hitchcock. I'm the president and founder of a company called EOC1. We're a validation company, a certification and validation company, and we service about 700 medical facilities across the United States. We routinely travel as far north or from the Caribbean all the way up into Virginia and across to Idaho and down through Texas, New Mexico. So we have a pretty large footprint. How I got here is I was actually a director in healthcare for a few years, and I kind of realized there was an opportunity to fill a gap in terms of knowledge because I was really kind of seeing that, you know, we're definitely in the space of safety and health. But yet, it seemed like there was always a lot of questions about how we could do things more safe, how we can be more health-minded relative to not only biological hoods, chemo hoods, which quite frankly are the same thing, clean rooms and all those sort of things. So I've been doing this work. I have been a Department of Defense trained industrial hygienist for this coming March. Will be 32 years. So, and I've been in business for about 14 years, and I have a full staff of people to do the certification. We have a training department, and so we are more of a boots on the ground, get in the facilities type of company.
Awesome. Appreciate the introduction. Herschell and I go back many years ago when I was working for a manufacturer. He and I would talk frequently, and actually we still do talk frequently because there's certain things about engineering controls that I need him to demystify. And like I mentioned many times before, he's in my network of folks because I'll be the first to admit I'm not the smartest person in the room, and that's why I rely on folks like Herschell and some of the consultants from weeks previous. So Herschell, you've got kind of an interesting story you want to tell us or something that that you just really want to get out there for our audience to understand more about, especially those independent pharmacies, as it relates to the testing of HEPA filters and that validation process?
Absolutely. USP 797, the current edition of USP 797's language relative to testing of HEPA filters is really not that stringent. It literally just states that HEPA filters shall be tested in place and by the manufacturer, and it really doesn't get into how often they should be tested. Some states, such as Florida, Texas, and Virginia to some level, have really started kind of viewing sealing HEPA filters testing to be a 6-month requirement, even though USP doesn't say it. Then on the heels of that, I learned just yesterday that JCHO, as part of their inspection criteria, is now asking for those test reports on HEPA filtration. And that kind of mirrors the CETA, which is the Controlled Environmental Testing Association's CHE guides on testing of clean rooms, which also makes a recommendation of every 6 months to test the sealing HEPA filters. So we're starting to move from an environment to where there's some ambiguity as to how often those filters are to be tested to being more a normal part of your routine inspection criteria or certification criteria. And so what we're finding, though, is that oftentimes facilities do not have the ability to insert or to inject the test media immediately upstream of these filters, which ultimately leaves the result of the test protocol in question. So I'll give you a case in point. We had, and I showed you a picture of this, but we had a hospital in which the certification company had put the challenge aerosol in the return air vent of the air handler. And through just normal migration, more normal air movement, and those sort of things, then there is a hope that the challenge reaching the filters is adequate to test these filters. Now, the testing of filters is outlined in the IEST standard, which tells certifiers how to do this test. So part of that test requirement is that we really have to know what's upstream. We have to know what the concentrations are in terms of how much aerosol or how much test media that we're using. And then we also have to be assured that the mixing of that upstream media is evenly distributed across that full filter face prior to testing. And it becomes very difficult to put enough aerosol into a return air vent to really kind of be assured of that concentration. And it's also difficult to do what they call where you're actually measuring that concentration prior to testing the filter. So ultimately, what we hope that people do is to actually put in what they call an injection port, in which the aerosol or the test media is put immediately upstream of the filter, and is basically you're isolating that individual filter against a known concentration, because the acceptance criteria for this leak that's established in the IEST standard is 0.01% of a leak. So you can imagine it's very small numbers. So when you have an upstream challenge of 10, 12 micrograms per liter, which is how much media or how much challenge we could be generating, and then the acceptance criteria is 0.01%, so 0.0001 times the upstream, you can see that those numbers are very small. And that's the reason why when you shove that test media in the return air register, by the time it goes through the ductwork, it goes through the condenser coils, it goes through the fans, it just becomes a very difficult, it becomes very difficult to be certain of your challenge without measuring that concentration in some way. And once again, we now are getting back to where we need to put injection ports or some sort of test port to do that test. So we recommend our companies to put injection, or recommend clean room companies, people that are building clean rooms, to put injection ports in to where we can do that test very easily. And then the other thing that we're kind of running into is that there's not a lot of clear guidance relative to, there are some sealing HEPA filters that have an injection port in them. Those injection ports are small, something to the tune of about 1/4 inch in diameter. And it becomes questionable as to whether you can get enough aerosol through that small of a port. And in fact, there was a research paper that was done by the Lawrence Livermore Laboratory that tells the testing guys that you must have at least a 1/2 inch opening orifice to inject that test media. So, I think it's important that people put in the test ports. That way there's no question, because 0.01% of a leak is a tiny number, and it's better safe than sorry.
So let's rewind just for a second, because I want to kind of unpack what you were talking about there. And for our audience, which is, the independent pharmacy, hospital pharmacies, they may not understand when you say test media. That test media is really, it's like an aerosolized gas. We call it a PAO. And so in the scenario that Herschell was just explaining, and I'll let him kind of go through it again on a different level, is that the certifier was putting the PAO, the aerosolized gas, into the return grill and expecting that to pull up evenly, go back through the air handler, and then be distributed evenly through multiple branches of ductwork. And those ductworks are then direct connected to, say, 4, 5, 6, or 8 fan filter units. So you're not going to get that dispersion. And Herschell, tell us why that dispersion, that PAO challenge cannot happen, why that aerosolized gas will not go back through the air handler and then get evenly distributed.
Well, this can be a point of contention among certifiers. Really, I can literally put enough aerosol into the ductwork by using what they call a hot generation method, in which I put such a large volume of this aerosol that there's no question that I could get a downstream challenge. The problem with that mindset is that at some point that aerosol is going to come out of solution, whether it be condensing, whether it's, coating the condenser coils, whether it be settling on the filter face. So ultimately, in my opinion, because filters are very, very expensive, I try to introduce as little of this test media, this aerosol, into the ductwork system. And so, to your point is that, it becomes a bit of a dance. It's not a dance in terms of the science, but it becomes a bit of a dance to how to get just enough without getting too much. So going back to your question is how does this aerosol get knocked out of solution? So I want you to understand is that there's a thing called a Laskin nozzle, and that Laskin nozzle has compressed air that's bubbling into this oil, and this PAO, is actually an oil in which that air bubbles it up into aerosols. Okay, and that's what they call a polydispersed aerosol, meaning many sizes, but you come up with what they call a most penetrating particle size of aerosol going to that filter. The problem with that is that because it's poly and not mono, mono is a test that you would do at the manufacturers, because it's poly, you become very susceptible to a lot of environmental conditions affecting what they call your upstream temporal spatial mixing. Okay, so the IEST standard, it's IEST RPCC 0034. There's a section in there that says that if I challenge a filter, let's say I have a 2x4 sealing HEPA filter, that if I challenge this filter in the top left corner of the filter, then the concentration at the bottom right corner of the filter must be within a certain percentage of one another, okay? And the only way that you can get that is by adequate mixing upstream of the filter, and the adequate mixing can't be mixed so much that we are diminishing or reducing the amount of aerosol. So the reason why we're concerned with this is that, I'll give you a case in point. We had a client of ours. They were tested, and, the certifier did what they felt like they had to do because there was no injection ports there. They scanned the filter, and they showed no leak. However, a month afterwards, when we put injection ports in and when we were able to quantify the amount of upstream challenge, we found that the filter failed, terribly. And once again, is that we're only looking for a leak of 0.01%. So that certifier may have not been able to see of that level of resolution because the upstream may not have been mixed adequately, or may have had reduction in the aerosol volume because of the condensing coil knocked out some of the aerosol, or a myriad of other environmental issues.
So, Seth, you're hearing this from a pharmacist's ear. I'm hearing this because I've lived inside of this for a while, and I kind of understand, for the most part, what Herschell is telling us. But you're the intended audience here. You're the pharmacist. You tell me what type of questions that you have so that all this can bring clarity to the reasons why. You like to know why. We always like to know why. To help me understand what you're thinking right now.
Well, what I would think, my recommendation is, instead of leaving things to chance, is to talk with your certification company, have them go ahead and put test ports in place into the upstream of each one of your HEPA filters. That way, as opposed to getting into a conversation about this science or that science, it can kind of isolate, it takes away a lot of the discussions. Furthermore, is that for the untrained clean room inspector's eye, like the JCHO inspector that I'm talking about, which, by the way, was a very nice guy, if he sees that injection port sitting right there next to the filter or in the hallway outside of the clean room, he's not going to have any questions in his mind as to whether that testing is being done, because it's easily accomplished at that point. And so it's low-hanging fruit, and I believe to help these inspectors kind of get what they need is to give them, something visibly or visible to their eye, that they know that type of test is easily attained or easily achieved. And so my recommendation is to have the injection ports installed. We don't, there's companies out there that sell those test ports. We don't sell them. We just recommend that they get put in by your clean room construction company.
So is there a litany of tests that you have to go through when you're coming in to certify a room? What are all those tests aside from the leak test? I think I actually understand that pretty well. And thank you for explaining it all. What other tests are there?
Yeah, you bet. I think that there is a host of tests. And, I want to talk about the regulatory environment that we're in to start with, and to share with you the importance of the STIDA guides here. There's a host of regulations. You have FDA guidelines on sterile compounding. You have USP 797, USP 800. There's other talk about other regulations. You have the other agencies, you may throw out PCAB, JCHO, and ultimately, I think all these people have the crosshair on the same issue. And so what is that issue? Well, the Controlled Environmental Testing Association has established a guideline for certification companies that in the absence of clear guidance, then they put together a guide, a STIDA guide. It's not a STIDA regulation. It's a guide for certifiers on how to certify these devices. But if I was going to paraphrase what a secondary engineering control certification looks like, it is a control. It's a test where you look at your air changes in your room, and depending on the type of ISO classification or the type of room that it is, whether it's like a hazardous drug storage room or whether it's an ISO class 8 room, those have their own performance criteria. Then there are criteria relative to differential pressure, which simply means difference of pressure between two rooms. Then you have criteria relative to how the room is built in terms of surfaces and wall coatings. But universally, the thought process behind the room construction design criteria is smooth, non-porous, and easily cleanable. Those are kind of the catchphrases on how you build a clean room. Then you have your that the room has to have HEPA filtration in it, or it can't. Even if everything else was in place, you still have to have HEPA filtration. Then you need to test that filtration, and then ultimately that then trickles down to the non-viable particle counts, which is nothing more than how many particles in a certain size are in the air for the ISO classified area, and then that kind of trickles down into the viable particle counts. So that's being bacteria and fungal or yeast contamination or whatever biologically active material is there. And then from there it goes to possibly chemical sampling. With the advent or with USP 800 coming up the line at us, we definitely have to be concerned about surface sampling for things such as chemo products, hormone products, and those sort of things. And those are becoming more and more important and it's becoming so much important that CETA is actually working on a new guide that's going to be CAG 11, which is going to address the Class 1 containment hoods for hormone and hormone type mixing processes.
So Herschell, help me understand about the surface sampling, say for the hormones, because to my understanding, the industry has not established a standard for which just the presence of contamination. There's no volumetric standard. In pharma, and we talked about this last week with Lloyd Allen, is that there are established OELs, those occupational exposure levels, or PELs, those permissible exposure levels, or limits rather. But when it comes to surface sampling inside of a pharmacy, inside of a clean room, and you surface sample and you do come up with the detection of the presence of chemo, that still doesn't, there is no industry standard, right? There's no way for us to say how much is too much or what level is an unacceptable level.
That becomes the holy grail because, we saw it with the thresholds that were in the system or inside of USP 797 in those thresholds that we saw for bacteria, yeast, and mold. Those became the levels or the permissible exposure limit, even though, there's some indication inside of 797 that, those are kind of designed to be baseline numbers. And I think that the same thing is going to occur with the hormones as well as chemo products. And by the way, we've been doing this chemo sampling now, our company has for, 8 or 9 years. And what we find is that our recommendation is until somebody establishes a true permissible exposure limit, I think that you kind of have to develop your own baseline number and use trends to assess your clean processes, because that's what we're talking about here, is that the lack of cleaning or the lack of improper handling, or quite simply the presence of an improper engineering control, can all contribute to environmental contamination levels. And because you have to measure that to see if your control system is working. And that control system is the cleaning processes. So, it's much like the the surface sampling historically for bacteria is designed to see if your cleaning processes are proper. Well, it's kind of the same thing with the hormone levels. I will share with you is that what I'm also realizing now that we're doing safety assessments and hazard assessments of pharmacies, that just because something is being done in a hood doesn't necessarily mean that it's safe. So I'll give you a case in point. We went out to do air monitoring for hormone products in a facility, And we realized that the hood that this facility was using, which was a new hood in fantastic shape, had been recently certified. The way that the hood was designed, it was not designed to contain large particulate matter products. And what was happening is there was a gap underneath what they call the airfoil, which is part of the entry into the hood. There was a gap between the airfoil and the bottom of the hood itself. And because of a work process, large particulate hormone products was actually being pushed out of that gap and into the work zone or into the workplace. And so ultimately, just because something's in a hood doesn't mean it's safe. You have to do a safety assessment or an industrial hygiene assessment to make sure that your engineering control is adequate for the type of risk that you're being faced with. And that all kind of feeds into the monitoring, you know, the remote, where you're trending your results, you're looking at your cleaning processes, you're doing a safety assessment on the engineering control. It's definitely not a one-size-fit-all type solution. You really kind of have to critically look at every part of it.
Herschell, thanks so much for being on this week. We really appreciate your insight and expertise on clean rooms. If you're looking to possibly change who certifies your room or like an opinion on an issue you may be having, feel free to reach out to Herschell. Contact him through his website, eocone.com. Like Brian said at the top of the show, we'll be at the American College of Apothecaries annual meeting February 28th through March 3rd. We'll have a few microphones and we'd really like to hear from you, so if you have a chance to stop by and say hello, please do. Speaking of the ACA, I'll be doing a live webinar on environmental monitoring for the ACA on February 22nd. This will be a compounder's guide to environmental monitoring and remediation. This is the meat of what you really need to know about environmental monitoring, so I really hope you join me. I believe there's a limited number of spots, so sign up at vetmeds.org/education/webinars. Thanks again for listening. I hope you enjoy as much as we do. Feel free to send us comments or questions to podcast@pharmacyinspection.com. Follow us on Twitter @pharmacyinspect or Facebook, Instagram. We hope to hear from you. And by the way, please direct any issues to Brian, business, or even just personal. He'd love to hear from you. We'll see you next week. Until then, keep raising the bar.